Hello. So in this video, we are going to see and or experience the number one mantra of math people, embrace laziness. So we're going to be talking about the generalized model. So we talked about the numeric model a little bit. So for numeric models, this was the idea of basically you have some problem given to you. Like we had this idea of, okay, if we have this sort of rectangular shape, right? We wanted to be able to get a sort of verify whether the corners were 90 degrees or not, right? This kiln base. So came up with this idea of being like, okay, if we measure the sides, right, and we know that the sides are straight, then we can use the Pythagorean theorem, right? And we try to get the diagonal and see if the diagonal is the right length, right? So we had that classic a squared plus b squared equals c squared. In a second, we'll see why I have these labeled in different letters, but this is just a sort of recalling, right, from that previous numeric model. So we calculated what that was, the 90 squared and 60 squared. We calculated c with, in this case, a calculator, because these are not very nice numbers. And we got something like 113 point whatever, right? And the idea was then if we measured the diagonal, and if it was that length, then we knew it was a right triangle, and that gave us the 90-degree angle. But the problem is that again, this really did happen. My mother came to me and was like, okay, we have all these other substructures that we have that need to be, have these right angles. And how can I tell if they have right angles? Again, without having the proper equipment to actually do this. So instead of going through each one of these one by one and being, calculating it out and being like, okay, here's, the diagonal you need for this one and the diagonal you need for this one and all of that. Instead of doing that, right, embrace laziness. What I did instead was I sort of drew up the plan for how she could figure it out more or less on her own. So to do that, I took the numeric model I had and I translated it into this generalized model, right? So that's the goal. And to this end, I took my original sort of statement here, right? My a squared plus b squared equals c squared. And I put in instead letters for all of the numbers. And you'll note that I changed the numbers. And why, again, I'll say in a second. Change the letters into different letters, and I'll show you why in a second. But the idea is that D here, right, I made a little mock-up square, right? And the whole idea, right, is to get this D length, this diagonal, so that if you had the right diagonal, then it would be a square. So I knew that I'd need to have that diagonal, just like I needed the c value down here, right? So I solved for d, square root both sides. And then I took that thing, and I basically wrote this out on a piece of paper for my mom. And I wrote out this, d equals square root of L squared plus W squared. And I wrote underneath, calculate d with a calculator and measure the diagonals. So I presented this piece, right, with the little square mock-up so she could see what I was talking about. And then I wrote underneath a note, right, this key to let her know what each of these things were, right? So L, length of the rectangle that you're looking to check. W, the width of the rectangle you want to check. D, the length of both diagonals need to be, right, that length in order for the rectangle to have 90-degree corners. And at the bottom, I wrote a little note here that I said, L and W, these things are interchangeable. It doesn't matter which one you want because, right, you can just rotate the square, and it doesn't matter which one you labeled which. So just so that she knew it wasn't important that she made sure that L was this way and W was that way. You could do whichever way you wanted. So this is an example of a generalized model where I took the sort of number version and replaced it with letters. And the idea was I could hand her this piece of paper and she could check all of the different things she needed to see were square and not actually have to come back to me each time and make me do more calculations each time, right? Hand her one thing and I can go back to reading my book or, playing a video game or whatever I was doing instead of having to keep doing different ones for different structures that she wanted to check. So there's a couple things to note here. First and foremost, I didn't include my work, right? So when I wrote out the Pythagorean theorem and then I solved for d by doing the square root on both sides and all of that, I didn't go through that on the piece of paper because there was no need to. She didn't care about how I got my answer. She only cared what the answer was. But nonetheless, I still had my work, right, on another piece of paper so that I could actually demonstrate it if she wasn't sure how I was coming to these magical formulas, right? So I had the work to justify my result, but I didn't sort of include it in the model. The model is just the end result. So Another thing, right? Although L, W, and D, these are all just letters, L and W, you might notice, are playing fundamentally different roles than D, right? L and W were the length and the width, and those are things that were known. D, on the other hand, this is something that was unknown. She had to calculate that and actually verify. That was the sort of important number in all of this. This is the output of the generalized model. And we'll get into sort of how this stuff is different exactly. It's just sort of important at this point to note that there are sort of some, even though they're all letters, there are some letters that play very different roles than other letters. And we'll talk about types of variables and stuff later. Also worth noting, and I mentioned this before, I renamed these letters, but I renamed them to be intuitive, right? Like with the Pythagorean theorem, I know what I'm doing in my work. I have A, B, and C, and I know what these letters mean because I'm the one who wrote them down on the piece of paper. But if I were to just hand somebody these letters, they may not know, right, because I didn't show my work, they may not know that that's the Pythagorean theorem. They have no idea where A, B, and C are coming from, what they're supposed to be, or any of that. So instead, I renamed them, right? L, W, and D, length, width, and diagonal. So someone who didn't go through the process, who didn't realize I was using Pythagorean theorem, they would look at these letters and it would still be intuitive what they were supposed to be, right? They could, if I didn't have the key there, they could easily guess what the letter was supposed to represent. And finally, the process, right, of trading out these values for variables and then coming up with some sort of algorithm or some sort of sets of steps that they can go through to get the answer they want. That process of going from a specific example to these variables that sort of are more generally applicable, that's exactly what the general model is, right? So the generalized model is this idea of taking a numeric answer, something that worked in one specific situation, and being able to apply it in a number of different situations, right? By changing out what the specific letter values are, okay? All right, so what do we do? Well, we talked about the generalized model, right? And this idea of embracing laziness, this idea that by replacing certain numbers with letters to allow for variation you can go from sort of a very specific answer to a much more generalized answer. And that way you don't have to actually keep recalculating and re-going through the process every time. You can have sort of one set of steps that works in a bunch of different areas and hand that off, and that way you can go and read a book, play a video game, watch a movie, whatever it is you want to do, while somebody else is actually going through the work that they're supposed to be doing. That way you don't have to keep doing it time and time and time again. Okay? So that is that.